Okay, it's noontime Central Time. We'll get started. Previous four session, we are talking about the tokenizer and also the parser. It's a Lex and Yacc part of the theory of the compiler. And then today we are on a example using Python Lex-Yacc. Okay, Lex-Yacc is compiler. So here we use the Python version, we call it PLY, Python Lex-Yacc, okay? It's a PLY for calculator design. Calculator is a language. So we are going to talk about the overview of the PLY, Lex theory and building the Lex with PLY-Lex and the Yacc theory and building parser with PLY-Yacc and the interpreter design for calculator language. So Python Lex-Yacc, okay. Lex-Yacc is Lexer and Yacc is compiler. They are in C, C++ language, and you need to set up the Lexer file and .y file, .l file, and then you need to use the Lexer, and that's called Rex, okay, in Windows version, and also Python for the Yacc part to generate the Lexer and the parser portion, and then include it in your main program to create a compiler. Right here, the Lex and Yacc are module in Python. You can just import them, and then your Python program can directly use them. There's no need to create extra .l.y files. You just write those semantics and also the grammars in Python format, Python program format, function format, that would be good enough. So that's very convenient to use in Python. And Python is good, but the performance for the compilation is slow. So usually we suggest you to use Python as a prototype of a certain language prototype. But PLY is very efficient, and it actually is using LALR1 parser. So this person called David Bailey is a professor at the University of Chicago. I think very close to where Louis is. I believe that she's still a professor over there. So it actually is a technology developed in Illinois. And okay, whatever, you can actually just these are the overview of it, and you can actually install the Lex.py and Yacc.py and then import them. That's called PLY, okay? And then Lexer part, you may have a x equals 3 plus 42 times s minus t. So you be tokenized to this, and then the token category is like this. Let's assume these are different tokens. These are the token types. So token type, you have ID equals numbers equals for equal sign plus numbers times left parenthesis, right parenthesis. Okay, ID minus ID. Okay, these are the different type. So you will have create couples of the token and the token type. Okay. So you actually create the tokens. Tokens are the token type is actually is a tuple of different strings. And then the regular expression for it is R, it's a regular expression string, okay, and then slash plus, that's actually the plus signs, one single plus sign symbol. Minus is one minus symbol, times is a star symbol, divide, okay, these are the symbols that set up for the regular expression for the tokens. And then the action rules, action rule for number, you put a T underline the number rules T. So you look at here. And then if the T is a T plus is one plus number, one plus number is one plus digit, it is a number. So you use the T, evaluate the T, that's your value that you got. So this is your action rules. New line, if it is n plus slash n, and then illustration symbol, and then plus is this symbol, maybe one or more. In that case, you will evaluate it, and then the length of this T may have multiple symbols. Multiple symbol, it will increase how many lines. And then error is you actually face an error, you print the character zero value, and then next cell skip that error characters or tokens. So you call the Lexer, and then you actually call the Lexer, and then each data will be passed one by one according to the number and the new line. So right here, it actually do token, and every time you create a token, that's a symbol, that's a string. And then if it finish, you will actually get out, okay, get out of it. And if you don't get out, you actually got a token, and then you print it. So right here, you should print out 3 plus 4 times these different symbols, and you will get different token result like this. So that's actually each token is your laser token type with number, comma, these are different fields. The type, and then the symbol or value, and then the line number, and then the symbol number. Okay, these are the tokenization result. Okay, so tokens, you have different token type in the token list. You list down like this. So this one is a simple version. This version, we do not evaluate the calculator yet. It just read in line by line and printing it. Okay, this version is like that. Okay, and then this one is we will look at the reserved word like if, then else, and token. We have different one, and then we have the ID. We test the ID. Okay, and comments. So there are new line rule, find a column. Okay, building the necessary. So there are digit rule and non-digit rule, ID rules. Okay, so right now we have a new version. We have the token similar as before, the symbol similar with before, the number function, the new line function, the error function. Okay, and then you do laser input of 3 plus 4. Okay, and you create different tokenization. This is similar. Okay. And then next one, previous one has no class. Now next one, we have a class-based design. Class-based design, we actually have a my Lex-Slider. So basically, the my Lex-Slider is a new class. Okay, and it actually extend the object class. And the token type is the same, the regular expression is the same, the number rule, new line rule, and error rule the same. We have a bill. Bill would actually group up the parameters and values into parameter list, and then feed the parameter dictionary into your Lexer. Okay, and do that. So basically, we run the my Lexer and then the bill. The bill would actually call the Lexer. Okay, call the Lexer, and then M is your object. And then M dot test, you put your input as 3 plus 4 to the test function, and this test function would actually put your string for the class input to the Lexus input. So Lexus become a instant variable to the my Lexus object, and the string is passed to the Lexus. Okay, so this one you still get a similar result. Then you can also design it as object-based design. So there are several DS rules. The first one, there's no object, just directly calling the Lexer. Second one, you call the Lexer, but in a class-based design. Next one, we are object-based design. So object-based design, you still port your breed Lex as Lex. And then there are different token type, and then rules, and then you create using the my Lexer, the class to create a object Lexer, and the object Lexer take the input. So this one similar to previous object type, class type. Okay, so this just different version. We actually don't waste too much time on this. Okay, next one we talk about parser. Parser, you actually will write your uh, content-free grammar into this kind of the extended vector snore forms. And you want to have the grammar and action write down. Okay, we talked about this in previous chapter. So these are the parsing steps when you parse 3 plus 5 times 10 minus 20, and then there are actions and their input tokens and their actions shift and reduce. So Yacc is the parser part for the compiler. And then here you import a pre.Yacc, and then you from the calculator Lexer, you import tokens. So the tokens that you got is the same as the previous Lexer. And then you add those action rules. So you got a plus expression. You put the 1 plus 3, you have A plus B is 1, 2, 3. You actually do 1 plus 3, and then it's stored at the 0. 0 is your left-hand side value. So that's also you have the sum equals A plus B. This is P1, P3, P2. This is P0. Okay, for a rule, or a plus sign rule. Minus sign rule is like this. Okay, assignment rule is like this. Times rule, dividing rule, vector rule, vector number rule, vector expression rule. Here you see that this is the definition of that rule. Okay. Term defined as term divided by vector. Okay, these are the rules of the grammar and expressions. So Yacc, let me see. Okay, it's different rule, and then you call your Yacc function that create a parser, and then you wait for the input string. This is Python's wait for input string. You got a string, and then if you got data in the string, you pass it and get result. Pass it, get result, pass, get result, and here it's done. Okay, so it's not hard. Okay, so you show you each step how they parse data. So this one basically you need to learn how to write the rules for the different language, and then this pre will automatically uh, do parsing for you, and it can be used as a interpreter by itself. Okay, anyway, next one is the construction for abstract syntax tree. So you talk about your, I know a binary operator, expression plus expression, expression minus expression is kind of things. You got the binary expression, something like this. Okay. So talk about how to construct a AST using Python function. Okay, the next one is multi-line, multiple parser and Lex-Yacc. You can include multiple Lex-Yacc and parser into your program. Okay. Okay, anyway, here today we just briefly talk about the purpose of learning this pre, but in fact, you need to practice a lot because this one is give you an introduction to the pre, the software, and you can only learn it by working on the real examples. Okay, thank you. Bye now.